Greetings and welcome once again. My name is John Gabriel, and this is the new calculus channel. And my favorite whipping boy is this mainstream idiot. I'm sorry, I consider him an idiot, and my IQ is above 160, so chances that I'm wrong are pretty slim. Okay. Anyway, so the first thing, one of the things that I mentioned in a previous video is a statement that he made about ds. Okay. And I showed you that in the new calculus, ts is not infinitesimal because there is no such thing as an infinitesimal. It's a garbage concept. So in this thing, what I'd like to do is talk a little bit more about line integrals and give you all the things that you need to know about line integrals, the important things, and the things which your professors normally miss out on, either because they don't understand or because they had some disconnect during their training, by the Church of Academia, which is the mainstream mathematics community. So there's often a lot of confusion amongst these people simply because they do not understand calculus. And by the way, everything in calculus, everything, there is no exception. Line integrals, definite integral, but every integral is a line integral, by the way. I think I explained that in the last video. But so, for example, I told you that even this is a line integral. And you may say, well, why is that a line integral? Can we not get a pen here with a shorter? How do you do that? I don't actually want such a thick line. Okay, never mind. Line, maybe if I do that, yeah, that doesn't really help very much, just makes it smaller. Never mind. So this here is a line integral. It's the line, it can be written as like that. Okay. And what that means is that inside here, you have dy dx squared plus dx dx squared, and that gives you 0 plus 1, which is 1. Okay, so that's why you don't see this and this, okay, generally. Okay, so that's one thing I wanted to mention. Maybe I didn't say that pretty clearly in the previous video. So there are no infinitesimals, and I showed you also in the previous video how you can get the arc length beautifully using the new calculus. In fact, it's unbelievable how it falls into place, and it's because of the mean value theorem. Everything in calculus works because of the mean value theorem. By the way, the fundamental theorem of calculus is the mean value theorem. And generally, what does the mean value theorem really says? It really say? Just a very quick summary. So it says if you have a smooth curve, and notice it has to be smooth, okay? It cannot just be continuous, like the idiots on Wikipedia say. It has to be smooth. And so if you have a smooth curve, what it says is that all the all the slopes here can be represented by, if this is A and this is B, and there's some C somewhere in the middle here, okay, some C, and it says that all the slopes inside here have a level magnitude that is represented by f of c. Now notice, you might get a little bit confused when we put f prime, but f prime is just a function, by the way. It's a function like any other function. I mean, I didn't have to call it f prime, and in the mainstream, the morons of the Church of Academia, they don't write f prime. They normally write f of b minus f of a is equal to the integral from a to b of f dx, because they've never actually made this connection very clear, okay? But the correct way to write that would be to have a small f in this statement and f prime in here, okay? F prime is just a function, nothing special about f prime. So this here is the level magnitude, or the lev mag, of all these lines, all these slopes, okay? And what the mean value theorem says is that from A to B, this can be given by f of b minus f of a of b minus a. The fundamental theorem says that it's also the mean value theorem, and it says that the area under f prime. Now, so let's say f prime. I didn't mean to do that. Let's say f prime is given by something like that. I'm not even caring about whatever it is. So this is f prime. Then it's saying that the area under this curve, not under f, okay, under this curve, because these slopes determine f prime, okay? The area under this curve is given by the product of the level magnitude by the area, okay? So that's what the fundamental theorem calculus says. It says f prime of c times b minus a, not the bullshit that you'll find in mainstream books with a capital F and little f. That's just total garbage. It just hides the understanding that you require so that you can make the connection. Okay. So coming back to our little parrot, Dave misplains. So he carries on in this video of his, and he talks, and he says nothing about the orientation, nothing about the signs, and he starts using these things over here and goes into the fundamental theorem, which I'll talk about, for line integrals, which I'll talk about in a little bit. But in a previous video of his, which I may have covered or not, no, I don't think I have. It's Green's theorem, which is this one here. He talks about the curve runs counterclockwise or the curve runs clockwise. Actually, this is generally not true, by the way. It doesn't run in any direction. So if you have a curve like that, you can evaluate the same line integral that way or this way. Okay, it's like the same, for example, when you're evaluating a simple integral like that. Okay, as long as you just evaluate it in the same direction, let's say from a to b, it will give you the same value, except that from b to a will be negative. Okay, that's all that is the difference in this orientation thing. So generally, the orangutans of mainstream will tell you that if the direction is anti-clockwise, then it's positive. So if it's anti-clockwise, they tell you then it's positive, meaning it's not really positive. All it means is that the area here is on your left. I mean, for example, you could get a negative result there too, but they don't actually deal with that. They're just a bunch of idiots, as I've said. So now let's summarize the main points. Okay, so let's say we have a line integral, let's say again over C. That's how it's typically defined, and a vector field F dotted with dr. Right now, so here you need to know a lot of prior knowledge, which I'm not going into, but you normally do it in Calculus 3, in a course on Calculus 3 in the US, and in other countries it's just done in a course in advanced calculus. So F is a vector field, right? And we can just say that F is a function of two variables, and it's given by X, let's say I, where this is a normal vector, I, and Y plus YI. Okay, I really want to see if I can make this. How do you? No, I want to make this line is too thick. Stroke style. Hang on a second. So stroke style. Yeah, that's better. All right. So now this is much better. So this is X. Oops, no. I think I messed it up there now. Let's go back there. No, no, that's even worse. Just let's say reset the canvas again. So if I have, no, I have to go there. So if I have, what does that do? Gosh, I should have done this before. All right, so leave it for the time being. So normally we say f of vector field f dotted with dr, and that it's xi plus yi. Okay, so f of xy is equal to that. Okay, and let's say the parameterization of c is given by ct is equal to t squared. Okay, then c is parameterized. Okay, if ct lies, let's say, between A, if T lies between A and is less than or equal to B, right? So that would be correct. So, and we say that we talk about a positive orientation if it goes from A to B, and a negative if it goes from B to A. But for if you evaluate B to A, then you just take the absolute value of that, and it will equal to A to B. Okay. So this is the first part of it. And then let's just clear this again. I really need to look at the thickness of that damn pencil. Okay. What is this? No. Huh. Stroke width. I want that stroke width. Let's try this again. I mean, this is incredible. So Professor Dave does not explain these facts. He just brambles on about anti-clockwise being positive and clockwise being negative. But more importantly, orientation is irrelevant if the line integral, pay attention to this, it's irrelevant if the line integral that is needed does not go around a closed area. In other words, it's found on an unbounded area. So if you just have a line integral like that, oh, that's much better. Then you really don't care about the positive or negative orientation as long as you're just going from this point to this point. Because, for example, if you had something like this and you started from here and you went from here to here and then from here to here and then from here to here, and then let's say you just went back again the same distance on this side, you'd want to do it in this particular order, right? So you'd want to go from 0 0 to, let's say, 1 0 to, let's say this is 5 5 to this point here, which we'd say is maybe 5 6 5 6, and then we'd go 5 on this side, and obviously it would just cancel out this guy here. So that would be the actual value of the integral. So we don't care about direction at all if we're told the points that we need to go from. Okay, right. So orientation and all that is total garbage, not needed there. So the gist is that you only choose a direction and you stick with it throughout unless you wish to deviate, which means you have the points. And of course, negative values are generally irrelevant unless you're dealing with a scalar that can be negative. Well, it's actually positive, but it indicates something below zero, something like temperature or depth, etc. But let's see. Okay, then the final thing I want to discuss is a conservative field. So a conservative field, F, right? So if you have a conservative field, F, this means that let's say in any part of the field, if you evaluate a line integral and it has the property, conservative field has the property that that line integral will always be zero. Okay, that's what it means when it says a conservative field. And it doesn't matter which direction you take as long as you're consistent in the directions. So that's pretty much it, where the notion of positive and negative directions are concerned. And then, of course, the way that Green's theorem is taught, which is in this video here that I'm pointing to, is also kind of confusing to students because they think there's something special about the curve running counterclockwise or clockwise. It doesn't matter which way it runs if the area is bounded, as long as you know that one direction will be negative and the other one will be positive. And it only matters if you can have a negative quantity in what you're evaluating. Okay? So that's pretty much it. If you're not already a subscriber to my channel, become a subscriber. Follow me on Academia.edu. I'll place all the links in the details section. I'm sorry my videos might seem to drag a little bit, but it's all due to the fact that I don't see very well, and I'm trying to rectify that. I've had a lot of vision changes since I had glaucoma surgery in my left eye. Sometimes I see well far away and sometimes near. But so far I haven't been able to see normally with my left eye, which is amblyopic. So anyway, if you're feeling generous, buy me a coffee or a meal at the link I'll provide in the details section. It's a GoFundMe page, something like maybe $10, $15, $20. That will buy me a very nice gourmet cup of coffee or even a nice little fast food meal. I'm not wealthy. I don't earn anything from these videos. That's pretty much it. If you have any questions, one question at a time, please, because again, I have trouble looking at a computer for a prolonged period of times. I can't really do this for longer than about 15 to 30 minutes. And you can also join our Discord site, to which I'll place a link. You have to take a little test of 10 questions. It has mostly multiple choice and I think a couple of true or false questions. You can take it as many times as you like to pass. You have to get 10 out of 10. The reason I do that, or we do that, is so that we can eliminate trolls and especially mainstream academics who are there to disrupt, because they tend to be a bunch of cranks who do not like anything outside of their echo chamber. People like, for example, Dave and all the others. That's pretty much it. My name is John Gabriel. This is New Calculus Channel. Till next time, goodbye.